Welcome to the Hypertherm Cutting Institute video XPR monthly check sheet. This short video will cover the steps that need to be taken to complete the XPR monthly check sheet. By performing the monthly checks, you can be sure to find small problems before they impact production. These checks also help to ensure good cut quality and longer problem-free operation. This video covers monthly checks for the XPR system, but does not include other monthly checks that may be suggested by the table manufacturer or other components that you may have installed on your cutting system. Information on how to perform the monthly inspections can be found in the XPR 300 Preventative Maintenance Instruction Manual on Hypertherm's website. We will start the inspection with the first item: clean inside the plasma power supply. Always make sure that power is removed from the power supply and allow time for any residual voltages to dissipate prior to removing any panels. Cleaning the inside of the power supply should be done before the inspection with the exception of coolant leaks. You will want to take note of any coolant leaks before cleaning so you can try to identify where the leak came from. Remove the side and back panels. Using a low-pressure air nozzle with clean dry air, not to exceed 50 psi or 3.4 bar, or a vacuum, remove any accumulation of dust and particles from the panels, fans, heat exchanger, gas connect console, and torch connect console. Be careful not to damage the circuit boards during this process. The use of a mask is recommended if using compressed air to prevent inhalation of the dust. Next, examine the contactors. The XPR system uses two contactors, the main contactor and the inrush contactor. Both can be inspected the same way. You are looking for black or rough surfaces on the contact points. If this condition is found, replace the contactors. Burnt or severe pitting can cause phase loss conditions and may damage other components such as the choppers. Also, look at the electrical connections. Verify that the connections are tight and are in good condition. Finally, verify that the contactor is securely mounted inside the power supply. The next check calls for an examination of the pilot arc relay. Removal of the pilot arc relay cover will be required for this inspection. The pilot arc relay will be inspected the same way as the contactors. Look for blackened or pitted surfaces on the contact points and replace as needed. Also look at the coil. The pilot arc relay utilizes a magnetic relay and may build up metal dust. Over time, this may short the contacts or cause the contacts not to move freely. This may result in poor cut quality and poor consumable life. Some indications that the relay is not working properly may include short nozzle life, trouble transferring the arc to the workpiece, or no pilot arc when starting the torch. Replace this relay if there are any questions regarding its condition. Next, examine the coolant system. Look at all the coolant tubing connections inside the power supply for leaks and pay close attention to the areas you tagged during cleaning, since we know that the coolant leaks were present. Repair any and all leaks before further operation of the system. Other components that need to be checked include the torch lead, torch connect console, gas connect console, and torch head. Next, perform a coolant flow test. Visually look at the CNC or XPR web interface screen to check the coolant flow rate. Make sure that the coolant flow rate is between 3.79 and 9.46 liters per minute, or 1 to 2.5 gallons per minute. Obstructions in the coolant loop, such as debris, kinked, damaged, or spliced hoses, may cause the flow rate to decrease below the minimum value of 1.2 gallons a minute. Follow the procedure in the Preventative Maintenance Manual on conducting a coolant and filter change. Contaminated coolant can also block the heat exchanger. Next, examine the gas line connections. Check all the gas line connections using the system diagram to identify all the areas that need to be checked. Spray each gas line connection with soapy water or leak check solution. Look for bubbles on any of the connections indicating a leak and tighten the fitting. If the fitting is already tight and you still have a leak, replace the hose assembly and/or the fitting to resolve the problem. Some of the connections on the XPR use push-to-connect fittings. In some cases, an indent can form on the nylon tubing and create a leak. Usually trimming the hose 3.175 millimeters or 1/8 inch will fix the problem. Only remove what is necessary to avoid making the hose too short, causing the hose not to seat all the way into the fitting. Next, examine the hoses. Examine each hose for kinks, wear points, or sharp bends that can restrict gas flow or cause damage. If a cable track is being used, verify the hoses are not twisted. Do not splice hoses. This may cause a restriction and affect cut quality by changing the pressure and flow rates within the system. Replacement of the complete hose assembly is recommended for the best system reliability and performance. Next, examine the cables. Examine all the cables for cracks or unusual wear. If the outside insulation is cut, melted, crushed, or any other damage is found, replace the cable. Check the connections. They should be secure with no signs of physical damage. Next, ensure there is proper grounding. Proper grounding is important for reliable and safe system operation. Using the grounding information located in the XPR instruction manual, examine the grounding cables for damage, cracked insulation, melted or burned areas, correct cable size, and correct routing. Check the connections for corrosion, melting, torque, and proper size connectors and hardware. Look at the grounding diagram found in the instruction manual and verify that all the components are grounded to the proper location. Finally, examine the table to workpiece connection. Examine the work lead, positive connection, where the work lead connects to the cutting table. This is commonly an overlooked item since it may not be readily accessible. Verify there is no paint, oil, dirt, or rust on the workpiece. This prevents a clean metal-to-metal contact between the work lead, cutting table, and workpiece, which may cause arc transfer problems. Another item to keep in mind when inspecting the table to workpiece connection is waste buildup in the table. This prevents the workpiece from making contact with the slats. For information on component replacement intervals, refer to the component replacement schedule found in the Preventative Maintenance Instruction Manual. This chart will provide the replacement intervals in arc hours of the power supply and may be viewed on the web interface tool for the XPR or CNC. Thank you for watching this informational video on performing the monthly check sheet for the XPR power supply. For other XPR videos and more, please log on to the Hypertherm Cutting Institute.